Alright, let's do a little intro on piecewise functions. Piecewise functions are called that because they're defined over a sequence of intervals, which you can think of as pieces. So it's not just simply f of x equals x squared or something like that. It's f of x equals x squared if x is less than or equal to 3, but f of x is 9 if x is between 3 and 5. But it's this different kind of thing if it's negative x minus 5 squared plus 9 if x is in this certain range. But it's f of x is 2x minus 16 if it's this other certain range. So that's why they look strange. They behave in different ways over different intervals or pieces. So you have to describe how each piece works. So that's why you put it in brackets and describe each section. And you have to describe the range or the interval over which this behavior is valid for the function. So there's different ways of doing this. This is pretty standard though. So here, yeah. So I've got this crazy function. It's just pretty useless, but it's a pretty clear example of what a piecewise function would be. And so let's practice figuring out the value of let's evaluate this function at different places along its domain, just to practice this concept of a piecewise function. So f of 1, of course I can just look at the graph, and if this is 1, sorry, I didn't actually label my axes or my points here, but 1, 2, 3, etc. F of 1, well, I can just see from the graph that f of 1 is 1. But let me show you, if you don't have the graph, here's what you do. So I want f of 1. I want the value of f where x equals 1. So I have to find what behavior applies to this. Well, f of x is x squared if x is less than or equal to 3. Well, 1 is less than or equal to 3, so this is the rule that applies to this value of x. Okay, well, now they know that this is the behavior that's happening at x equals 1. I plug in 1 into this expression. I say 1 squared equals 1. So the value of this piecewise function at x equals 1 is 1. F of 4, well, 4 is not less than or equal to 3, so it's a different rule is going to apply. So here's the rule. So if 3 is less than x, which is less than or equal to 5, then what applies is that the value of the function is 9. So f of 4 would be 9. You can see that. See over this interval here, the value of the function is a constant 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if x is somewhere in here, the value of the function is going to be 9. F of 7. 7 is between 5 and 8, so this is the rule that applies. So when x is 7, I would use this part of the function. So I'm going to do negative 7. I'm going to plug in 7 for x plus 9. So 7 minus 5 is 2. 2 squared is 4. We got negative 4 plus 9. So f of 7 is 5, which you can see from the graph. 4, 5, 6, 7. 1, 2, 3, 4, 5. There. So this is a true story. Alright, last one. F of 100. Now, 100 is not on our graph, so we're forced to use the description of the function over here. So if x is greater than 8, this is the rule that applies. 100 is definitely greater than 8, so we'll use this one. 2 times 100 minus 16. So that's 200 minus 16. What is that? 184. So f of 100 is 184.